Good morning, everyone. Today we are starting a new module, Module 3 of Fluid Mechanics and Hydraulics. So this is the syllabus of Module 3. So hopefully we'll be covering the first topic of the third module today in this video. So the third module starts with fluid kinetics. Now, what is kinetics? It is a branch of mechanics concerned with the effect of forces on the motion of a body or system of bodies, especially of forces that do not originate within the system itself. So, in this fluid kinetics, we will be concerned with the effect of the forces that is acting on a body or a system of bodies, and especially the forces that do not originate within the system itself. That is, we will be considering the forces acting from outside, and this branch of mechanics is known as fluid kinetics. Now, the forces considered in describing fluid motion. So here specifically we are considering the fluid motion. So what are the forces that we are considering in fluid motion? So according to Newton's second law of motion, so you already know what is Newton's second law. The net force Fx acting on a fluid element in the direction x is equal to the mass m of the fluid element multiplied by the acceleration in that direction. So you consider any direction, the net force acting on a fluid element in that particular direction will be equal to the mass of the fluid element multiplied by the acceleration in that particular direction. Or in equation form you can write it like this: Fx is equal to m into ax. Fx is the force in the x direction and ax is the acceleration in the x direction, and m is the mass of the fluid element. So in fluid flow, now as we said, we are considering the force effect of the forces acting on a fluid element. Now what are the forces that are present in a fluid element? So the various forces that are present are given here. Fg is the gravity force, Fp is the pressure force, Fv is the force due to viscosity, Ft is the force due to turbulence, and Fc is the force due to compressibility. So these are the major forces that are acting in a fluid element. Or in equation form, we can write it like this: Fx is equal to Fgx plus Fvx plus Fpx plus Ftx plus Fcx. So in this equation, x denotes the x direction. Okay, and Fg is the gravitational force, Fv is the viscous force, Fp is the pressure force, Ft is the force due to turbulence, and Fc is the force due to compressibility. So these are the forces that are acting in a fluid element. So if Fc is negligible, so Fc is the force due to compressibility. So fluid getting compressed and the force exerting because of the compressibility, it is a very small quantity and it is negligible. So the equation takes the form Fx is equal to Fgx plus Fvx plus Fpx plus Ftx, and this equation is known as Reynolds equation of motion. Now, if Ft is negligible, then the resulting equation is known as Navier-Stokes equation. So this is the basic equation. From this, if Fcx, that is compressibility force, is ignored or neglected, then the equation is called Reynolds equation of motion. And from this Reynolds equation of motion, if the force due to turbulence is neglected, then the resulting equation is known as Navier-Stokes equation, or the Navier-Stokes equation will be Fx is equal to Fgx plus Fvx plus Fpx only. Okay, so if the flow is assumed to be ideal, then viscous force Fv is equal to 0. What is an ideal fluid? For an ideal fluid will be having no viscosity, or force due to viscosity will be 0. That is, the second term will be 0. So the equation, then the resulting equation is known as Euler's equation of motion. So what will be the resulting equation? Fx is equal to Fgx plus Fpx. So this term Fvx is 0 when we are considering an ideal fluid, and that resulting equation is known as Euler's equation of motion. So the equation, we are coming in detail to the Euler's equation of motion in which the forces due to gravity and pressure are taken into consideration. So in the previous slide, we had learned that This is the basic equation. If this FCX is cut, then it is known as Reynolds equation. From that, if FTX is cut, then it is known as Navier-Stokes equation. And in the Navier-Stokes equation, when we are considering the ideal fluid, then the equation will be Fx is equal to Fgx plus Fpx, and that equation is known as Euler's equation of motion. So, or in short, in Euler's equation of motion, the forces that are considered are force due to gravity and the pressure force alone. Now, consider a streamline in which flow is taking place in the S direction as shown in figure. So, we are trying to derive the Euler's equation of motion. So, for that, we are considering a fluid element. So, cylindrical fluid element which is having a length ds and an area of cross section dA, and it is in the S direction. Consider a streamline in which flow is taking place in the S direction as shown in figure. So, S is just a direction other than x, y or z direction. We are taking another direction, S direction, and we are considering a fluid element having cross section dA and length ds. So here you can see the fluid element. The forces acting on the fluid element are the pressure force PdA in the direction of flow. See here, this is the uh, pressure force acting in the direction of flow. So here P is the pressure and dA is the area of cross section. Then what will be the pressure force? We know that pressure is equal to force by area. So pressure force will be equal to pressure into area. So P is the fluid pressure and dA is the area of cross section of the fluid element. So the pressure force will be P into dA in the direction of flow or in the S direction. Now the pressure force acting here in the other end of the fluid element, which is opposite to the direction of flow. Why we are taking opposite to the direction of flow? So when you consider this fluid element, here the pressure is acting onto the fluid element in this direction, whereas when you consider this end of the fluid element, the flow is going away from the fluid element. So that is why we are taking the direction in the opposite sign. So what is the pressure force that is acting at the other end of the fluid element? We have already told you that in this side of the fluid element the pressure force is PdA. So what will be the pressure force here? So we have written a similar condition in the hydrostatic law. So here pressure force in this direction or in this end of the fluid element will be P plus dou P by dou S into ds, the whole multiplied by dA. Okay. So here when you consider this phase, the pressure is P and the pressure force is PdA. Okay. So when you reach here, you have to consider the increase in pressure when the flow reaches this position. That is when the flow travels ds distance. Okay, so here it is P, the pressure is P here. So when it reaches here, there will be an increment of pressure. What is that increment? So P is already there. So P plus dou P by dou S is that rate of increase of pressure. What is dou P by dou S? Dou P by dou S is increase in dou P, pressure increase of dou P for a distance dou S. That is, when the flow travels for a distance dou S, the pressure increases by dou P. So dou P by dou S means that. So if dou P by dou S is the rate of increase, then what will be the increase for ds distance? Dou P by dou S into ds. Okay, so the total pressure force acting in this direction will be P plus dou P by dou S into ds. This much is the total pressure, and that whole thing multiplied by dA will give you the pressure force acting in this phase of the fluid element. I hope that is clear. So we have considered the two pressure forces in the fluid element, the pressure force which is acting in this phase and the pressure force which is acting in this phase. Now what is the third force? It is the weight of the fluid element or the force due to gravity. How will you get the weight? We know that mass is mass density is mass by volume. So mass is equal to density into volume. Weight will be density into volume into G. Okay, so here rho is the density multiplied by G, and then it has to be multiplied by the volume. What is the volume of this fluid element? dA is the cross-sectional area and ds is the length. Then dA into ds is the volume of the fluid element. So the weight will be rho into G into dA into ds. Rho is the density, G is the acceleration due to gravity, and dA ds is the volume of the fluid element. So these are the forces acting in the fluid element, because all other negligible forces we are not considering. We are only considering the pressure force and the weight of the element. Now let theta be the angle between the direction of flow and the line of action of the weight of the element. So here there is a marking of angle theta. What is that angle theta? See here, it is the angle between the direction of flow. This is the direction of flow, and this is the direction of gravity, or the direction in which the weight is acting, and the angle between the two is marked as theta. Now the resultant force on the fluid element in the direction s must be equal to the mass of the fluid element into acceleration in the direction x. So we know that according to Newton's second law of motion, the resultant force in the fluid element should be equal to the mass of the fluid element multiplied by the acceleration in the direction s. So here you have a very important step. This is the net force acting on the fluid element. This is the force on the first phase. This is the force on the second phase. And this is the weight of the fluid element. So why we have taken cos theta here? Because we have to consider the weight in the s direction, or the component of weight in the s direction. Rho g dA ds is the weight which is acting in the downward direction. But when you consider the direction of flow, that is when you consider this element, this direction of flow, you have to consider the component of the weight in that direction. So the net force will be P dA minus P plus dou P by dou S into ds, the whole multiplied by dA, minus rho g dA ds cos theta. What is this term? It is the component of weight in the S direction. So this is the net force. We know that the net force is equal to mass into acceleration. So mass is rho dA ds. In the previous slide we have taken rho g dA ds because that was the weight. Here it is mass, so rho dA ds multiplied by the acceleration in the s direction as. Now we know that as is equal to dv by dt. So here we are going to see some differentiation here. So as is dv by dt, where v is a function of s and t. Acceleration is velocity by time. So as is equal to dv by dt, where v is a function of s and t. And since v is a function of s and t, this dv by dt can be written like this. How do you write it? Dou v by dou s into ds by dt plus dou v by dou t. So this you have learned in the mathematics classes. So dv by dt, when v is a function of s and t, it can be written like this. Dou v by dou s into ds by dt plus dou v by dou t. We know that dou v by dou s is nothing but ds by dt is nothing but the velocity. So v into dou v by dou s plus dou v by dou t. Now if the flow is steady, then dou v by dou t is equal to 0. What is steady flow? Steady flow is a flow in which the flow parameters do not change with respect to time. So dou t is a component of time. So if the flow is steady, then dou v by dou t is equal to 0. That means this term is equal to 0. So this as can be rewritten as v into dou v by dou s. Now we can substitute the value of as in equation 6.2. This is the equation 6.2. When you write it in the notebook, you can mark this as equation number 1 and substitute the value of as in equation number 1. How do you get the equation now? So this by simplifying this equation, this P into dA and this minus P into dA will get cancelled. What is remaining? Minus dou P by dou S into ds. Minus dou P by dou S into ds multiplied by dA minus rho g dA ds cos theta is equal to P into dA ds into, this is the substitution for AS. So the equation takes this form. Now you can divide this equation by rho ds dA. So how will the equation become? Minus 1 by rho into dou P by dou S. This dou S dou A ds dA will get cancelled. Minus rho ds dA will get cancelled. So what is remaining? Minus g cos theta is equal to, here also rho ds dA will get cancelled, v into dou v by dou s. Okay, so changing the sign, dou p by rho dou s plus g cos theta plus v into dou v by dou s is equal to 0. Here there is only one v, you don't have to write this v. Okay, so it is v into dou v by dou s is equal to 0. Now you have to give a substitution for cos theta, that is given here. See, this triangle is drawn here again. So this angle is theta, this is ds, and this direction is dz. So from this figure, cos theta is equal to, see here, cos theta is equal to dz by ds. So it is obtained from that figure. So substitute for cos theta here, 1 by rho into dou p by dou s plus g into dz by ds plus v into dou v by dou s is equal to 0. Or dou p by dou rho plus g dz plus v dv is equal to 0. That is multiplying by ds. So here there is a correction. See, here dou p by dou s you have to write. Okay, so the multiplying whole by dou s, it takes the form dou p by rho plus g into dz plus v dv is equal to 0. And this equation is known as Euler's equation of motion.